from here onwards. Okay, so what we'll be doing is we'll be introducing very basic DC machine, basics of DC machine, and the sir, I think few students are waiting in the waiting room. Sir, mashal ko in kare. Is it the way to talk? In kare, yaar. Come on, beta. This guy Bilal Khan 7Y. I'm not here for saying your lucky number and not like that. Come up with your original name and ID or only your name, okay? And don't मुझे किसी की सिफारिशें ना करेंगे उसको अलाउ करें मुझे स्क्रीन में आ रहे हैं. I'm not gonna wait for you for the entire life. 15 minutes are gone. I'm not gonna wait anymore. Nobody's allowed after this. That's done, right? Please, there should be some rules. It's a class. It's not a joke, right? And I'm not waiting for your class to. I'm not waiting. I can't wait for individual to come to this class, right? So this is it. I'm not going to allow anyone. Don't try to tell me that allow that person or that person. That's done. I'm not going to allow any other person from now onwards, right? Till the end of this class. So basically we'll have be doing the introduction to DC machine. Sorry about this. The example we are doing is example 110 and only one part of which we are doing, and that is I think B part. So let's quickly go through what is a DC machine. So a DC machine is an electromechanical device, and it is just like a DC machine normally, just like a machine. It can be classified into two types, that is DC motors or generators, right? So the working principle is quite easy, and that is when the current passes through the when current passes through a coil within a magnetic field. So what happens that the magnetic force normally generates the torque, which ultimately rotates the DC motor, right? So normally, just like a conventional motors or generators, the DC machines are of two types, and that are DC motor or a DC generator. So what's the difference between a DC? Obviously, we'll have one entire lecture on DC motors and AC motors and its constructions. That was supposed to be done in the lab, but we'll be doing it at the end of the course, inshallah, right? So it is exactly the same as like the AC machine. The only thing it is that because it obviously contains or it includes AC current as well as voltage, but the output of it is a DC output, because what they normally do is that they convert the AC voltage to DC voltage. This process basically, or this mechanism, is also known as commutator, or so, and that for that reason it is also called as commutating machines. So this is one example. Again, I doubt it if you have studied DC machines in your course. If you haven't studied, I'll have a lecture on DC motors and AC motors and its construction and its working. So we'll study that in detail. But just normally going through quickly, we'll have the concept that DC, it is an electromechanical device, and it is of two types, either a motor or a generator. How it works is that when current passes through the coil, uh, within a magnetic field, the forces exert some generates some torque, which basically ultimately does the task, right? Which ultimately rotates the motor. So mostly, this is basically the example of a DC machine. These are the components, or these are the parts of a DC machine. So this is an example, which is and I think Chapin book 1, chapter 1, page 46, I think. This is an example that obviously there are three different figures. I've just considered this figure because this is concerned regarding to the example. It is saying that uh, a DC machine which is shown in the figure. Sorry. Okay. So it is the question is that the linear DC machine shown in figure this one has a battery voltage of 120 volt, an internal resistance of zero point 0.3, and uh, magnetic flux density of zero point 0.1 T, right? And what is it is saying is that the question is that assume that the force acting is pointing on the left to the left is applied on this bar. So basically as I told you that what happens is that the magnetic, due to the magnetic field, some force exerts and it ultimately works this line, uh, which ultimately generates torques which rotates the DC motor. So the force is assumed to be pointing towards the left of the bar, and what you do that as the function of the force values ranges from 0 to 50 Newton. So the force is exerted uh, in the form of like steps from 0 to 50 Newton in the steps of 10 Newton. Means like first is 0, then 10, then 20, then 30, then 40, and then 50. So it is just like in the form of some intervals, and that interval is in 10 steps, right? So basically, what is basically this so the question is plot the velocity of the bar versus the applied force. So basically the velocity that is exerted on this bar through that force which is nothing but pointing towards left, and that starts from 0 Newton and it ends at 50 Newton in the step interval of 10, right? So basically, let's make it as just like an FSC example. So what we have to do is normally is that uh, what are the data that we have is that the battery voltage is 120 volt, resistance is zero point 0.3, bar length is 10. Okay, why I'm not going through the book? The book, this part has made some mistakes, especially in selecting the length of the bar. They've selected at 1 meter, which is not right. It is nothing but it is 10, right? The and flux density is zero point 0.1, and the force which is basically 0 to 50, and the time step is 10. So first it will exert 10, then 20, then 30, and then 40, and ultimately it will exert a force of, ultimately it will exert a force of 50 Newton. So this was the the data which we need to have to obtain the thing which is basically we'll have to calculate velocity and apply and plot a graph between the velocity obtained versus the force applied, right? So it is quite easy, especially if you need to know the formulas of it. So basically the velocity of the volt bar, which obviously is given in the book as well, and you can find out how it is derived. But as we are just solving the example and we're not getting it depth, so just quickly, we'll say that velocity of the bar is nothing but the induced voltage in that bar, the voltage that is being induced in that bar, divided by the bar length, the length of the bar into the flux density. So what we have and what we don't have. we don't have the induced voltage with us. We have bar length and we have flux density. So now the question comes that the induced, what is the induced voltage in that bar? It is basically equal to the battery voltage minus the current into the resistance. This is the formula for that. Induced voltage is equal to the battery voltage minus current into resistance. So now the question is, why, what is given here? So here we have the battery voltage and we have resistance, but we don't have the current. So for the current, basically, if you look at uh, the current, so basically we have a formula which is basically F, the force is equal to the current into the bar length and flux density, or we call it as, like, it's like this way. I can open the paint so that I can write it here. So basically the main formula for it is F, force acting on the bar, equal to the I, this is I current, into length. आवाज गायब हो गई है, आवाज गायब हो गई मेरी अब्दुल्ला. Now it's fine. Okay. ठीक है, sorry. So it is length of the bar into the flux density. This is the formula. This is the main formula, which is basically force into the current, and this is I basically, right? And into the length of the bar into the flux density, right? So this is the formula. If, let's suppose, if I want to find current, so what I'll do, I'll divide this over here. So the formula here is, that is derived from that, is nothing but force divided by bar length into the flux density. So this is nothing but just like a reverse process, that first we'll find the current. From current, we'll find the induced voltage. And from the induced voltage, we'll have the velocity of the bar. And once we have the velocity of the bar and we have the force, so we just have to plot each other, right? Okay, so let's take this as obviously we'll be doing it in Matlab, because it is in the problem it is stating that normally the purpose of explaining the Matlab through this is that it will make your life easier, especially when there is a problem of plotting, right? So we take it as a Matlab problem. So let's say this one. So VB is battery voltage, it is 120, R is resistance 0.13, L is bar length, which is 10, B is flux density, which is 0.1. Normally, the purpose of this is basically this one. This is the way to write a thing which you need, which is being applied in intervals. Let's say, especially when you inshallah are in 7th semester, and there will come a problem of trajectory of a robot, and if life permits and if I'm there, I'll be teaching you guys a trajectory, how to apply the, like how to plot the trajectory. Trajectory means that you need to know the position of that robot at every interval of a time, at a specific interval of time. Like let's say, sir, here is in machine we have beta. I'll get to your questions once I'm done. Please don't stop me, and then I'll जो क्वेश्चन आंसर सेशन होगा हम उसमें सब कुछ करेंगे, ठीक है बेटा? अच्छा, तो द पॉइंट इज लाइक इन ट्रेजेक्टरी व्हाट विल वी डू इज, उसमें हम एक एक सिंगल एक एक टाइम पे हमें चाहिए होगा कि हम टाइम इंटरवल एक एक टाइम पे रोबोट की पोजीशन क्या होगी और उसकी ओरिएंटेशन क्या। तो व्हाट वी नॉर्मली डू, हम एक टाइम इंटरवल डिफाइन कर देते हैं कि या लेट्स सपोज एक रोबोट यहां से जा रहा है उधर तक जा रहा है 15 सेकेंड्स में। तो 15 सेकेंड्स में हमें क्या चाहिए, तो 0 से 15 में हर 2 सेकेंड के बाद हमें उसकी पोजीशन चाहिए for that trajectory. So what we do is basically we plot it like this, that 0 is the initial, 50 is the final, like in this case it is 0 is the initial force, 50 is the final force, and 10 Newton is the, sorry, the 10 Newton is the steps which we normally take. So this is basically nothing but the in the quantity that is being applied at each step. Beta, who is this Mahaz Ahmed who is coming right now, beta? So this is why we write it like this. Okay, let's Abbas who and Hamza, make this thing clear from next onwards class. 5 मिनट के बाद जो भी आएगा वो he or she won't be allowed in this class. यार ये कौन सी क्लास है, 30 मिनट मैं बक बक के बकवास कर रहा हूँ and then a person is coming after 30 minutes and then फिर कोई उसकी सिफारिश कर रहा है कि let him in. So this is basically, let's quickly clear this Matlab. Okay, so let's quickly run these step by step. F9, just to show you that how it works, as the problem in the example is uh, let's say this one, as the problem was in the question was that force is applied at 10 Newton step from 0 to 50. So basically this is the force basically applied. This command does that, first the force would be 0, then 10, then 20, then 30, then 40, and then last but not the least is 50. Okay guys, I'm leaving one question to you guys that I'm expecting from you guys, and those who ask me that question, I'll be giving him or her 2 marks for that question, and that question hidden inside the code itself, right? So if you go back to this one, the slide is this one. First we have to find the current, which is nothing but force divided by bar length and flux density. So we do this current force divided by length into flux density. So what, and then we find the resulting induced voltage, which is nothing but battery voltage minus I into R, right? And then last but not the least, the main thing which we are basically finding is the velocity of the induced velocity that is being calculated in that bar, right? So that is nothing but V induced from here divided by induced voltage divided by bar length into flux density, right? So this is obtained from here, we induced, and now we have the velocity and we have the force. So basically we plot it, we call this title as plot of the velocity versus the applied force. X label we call the label of X as force and Y label as velocity, right? So let's execute it in Matlab step by step, right? So we have done it here. Let's say we do it here. So the current that is found will be this. The induced voltage would be this, and the velocity will be induced as this. So now let's say we plot it. This is the plot. Let's say we just make some make it a bit stylish. Like obviously we have to add some plots. Sir, what the command for executing step by step? What is step by step? अब प्लीज बेटा लास्ट में जब मैं क्वेश्चंस खत्म कर लूं फिर आप क्वेश्चंस करें. जब तक आपके क्वेश्चंस खत्म नहीं होंगे आई वोंट लीव. राइट. So this is plot of the velocity, and we will this is x label and this is y label. So we when we plot it again, we'll have this one, plot of the velocity versus applied graph. This is force and this is the velocity, right? So just quickly wrapping the 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 part of Matlab part. Sorry guys. So we'll have the battery voltage, we have the resistance, we have the length of the bar, we have the flux density, we have the force applied on that graph, the resulting force that applied, we what we have to do is we have to find the velocity that is being uh, that is obtained through that force generation, obviously. So what we have to do is we have to find this equation. For that equation, we need to have the induced voltage. The induced voltage is this, and for induced voltage, we need to find the current. And from the current, we can find current with this equation. Once we get these values, what happens in that case is that we find the induced voltage, the velocity, and once we find the velocity, we plot it with respect to the force. Right? And once we plot it with the force, we explain, we give the title, and we have the X label and we have the Y label. If you see in the book, they've taken the wrong values, and once they've found it, the obviously their graph is different as well, right? So in the latest version, they've remodified that. I checked it through the internet, through this in others, in which it has been shown that yes, it is basically. Uh, so basically, this is how it works, right? So this is nothing but the thing that is being found. So again, let me repeat before the session ends, and we'll have the question answer session at after this. Remember at 12 o'clock, ये मशाल है क्या मशाल है, ये कौन है? मैं इसको जरा मशाल मशाल whoever he is जी. जी बोले आपको क्या मसला है मशाल और मशल, क्या मसला है आपको? ये आप बार बार क्यों जा रहे हैं और आ रहे हैं? हेलो मशाल, बताएं जी क्या मसला है आपको?